Hello everyone, welcome to Nolly Learning Center. Today we are going to solve a Chemistry 0620 variant 42 of Feb March 2025. Let us begin with the first question. Using numbers only, state the percentage of oxygen in clean dry air. So that we know is 21%. The second part, typical operating temperature in degrees Celsius used in the Haber's process. So for that, the operating temperature for Haber's process is 450 degrees Celsius. The third part, number of atoms in a diatomic molecule. So when we say diatomic, the word itself is self-explanatory that it will have two atoms. So the answer for this will be 2. Maximum number of electrons in the second electron shell of an atom. So as we all know that the maximum number of electrons in the first shell is 2 and the second is 8. So here the answer will be 8. The next one, number of hydrogen atoms in an alkane with 7 carbon atoms. So for this, let us apply the general formula for alkane, which is CnH2n plus 2. So if I put the value of n as 7, the answer will be C7H16. So the total number of hydrogen for this will be 16. Number of particles in 1 mole in standard form. So that will be 6.02 into 10 to the power 23. So with this we have completed with the first question. Let us move on to the next question. It says, state what is meant by the term ionic bond. So what is an ionic bond? It is basically strong electrostatic force of attraction between oppositely charged ions. So this will be the answer for the question. Let's move on to the second part. Potassium sulfide, which is K2S, is an ionic compound. Complete the dot and cross diagram in figure 2.1 of the ions in potassium sulfide. Show the charges on the ions. So as we all know, the electronic configuration of potassium in its natural state will be 2, 8, 8, 1. Whereas potassium ion will be K plus with an electronic configuration of 2, 8, 8. So here potassium will get a charge of plus 1 with one more outer shell electron having 8 electrons. This will be repeated for other potassium also. Now, sulfur in its natural state has 16 electrons, that is 2, 8, 6. Now it needs to accept 2 electrons. So in that case, the charge will be S2 minus and the electronic configuration will be 2, 8 and 8. So here there will be a charge of minus 2. Here there will be one more shell having 6 crosses and 2 dots indicating that these electrons have been donated from potassium. Let us move on further. The question says, ionic compounds form giant ionic lattice. The figure shows part of giant ionic lattice structure of sodium chloride. Complete the diagram to show ions present. Use plus for sodium ions and minus for chloride ions. So for this, ionic lattice has alternate positive and negative ions. So in that case, this will be a positive, this will be a negative, this will be a positive. Similarly, this will be a negative, this will be a positive, this will be a negative, and this will be a positive. The next question says, state the name given to any positive ion. So we know that the positive ion are called as cations. Next question. Ionic compounds can be decomposed by passage of an electric current using inert electrodes. State the name of this process. So this process is called as electrolysis, where electro means electricity and lysis means breaking down. Let us move on to the next question. Write the ionic half equation for the reaction which takes place at the anode, which is the positive electrode, when molten potassium bromide is decomposed by passage of an electric current. So we know that anode will attract the negative ion, which is bromine, and as it is molten, bromine will be formed. So for that, the equation will be 2Br minus gives out Br2 plus 2E. Now, as bromine is diatomic, we have to form it as Br2. Further, name the products and state the observations. Now, remember, when they ask observations, you purely have to write observations and not the conclusion. At the negative and the positive electrodes, when dilute potassium bromide is decomposed by passage of an electric current. So in this case, product at the negative electrode, that is the cathode. Now at cathode, according to the rules, we know if the metal is more reactive, hydrogen forms. So here the product will be hydrogen. Observations at the negative electrode, which is the cathode. So observation, as hydrogen gas is formed, the observation will be bubbles. Let's go on to the next. Products at positive electrode. Now at positive electrode, there will be two products, because for the positive electrode, the equation will be 4OH minus gives out 2H2O plus O2 plus 4E minus. So in this case, we are getting two products, which is oxygen and water. And positive electrode is the anode. Observation at positive electrode will again be bubbles, because oxygen gas is formed. So let us begin with the next question, that is question number 3. The halogens are a group of elements in the periodic table. Chlorine is the member of this group. State the group number of halogens. So we know that halogens are group 7 in the periodic table. So here the answer will be 7. Next question. State how many halogens are there in this group. So let us list down the halogens in the group 7, which is fluorine, chlorine, bromine, iodine, astatine and tennessine. So there are total 6 halogens in group 7. Let us move on to the next question. Suggest the identity of the halogen which has the highest density. So we know as we move down the group, the density increases. So the highest density will be of tennessine, but I will write it as TS2, as halogens are diatomic. Next is the most reactive. So we know as we move down the group in group 7, the reactivity decreases. So fluorine is the most reactive. Next question. State the name of the negative ions formed by halogens. So the negative ions formed by halogens are called as the halides. Next, state how many occupied electron shells are there in bromine atom. So the number of electron shells is always equal to the period number. So let us see in the periodic table in which period does bromine fall in. So bromine falls in period 4. So the answer for that question will be, there will be 4 electron shells in bromine. Next, name the noble gas which has the same electronic configuration as Br minus ion. Now Br minus means bromine has gained 1 electron. So in that case, bromine has 35 electrons, and when it gains 1 electron, it will have electronic configuration like krypton. So the answer for that question will be krypton. Next, aqueous chlorine reacts with aqueous potassium iodide. One of the products formed is iodine. Complete and balance the ionic equation for the reaction between Cl2 and I- ions. Now, as I know that chlorine is more reactive than iodine, so chlorine will displace iodine in a chemical reaction. So for the balancing, there will be 2I minus here, which will give 2Cl minus. As chlorine being more reactive, it will go into the ionic form. Next, explain why this reaction is defined as a redox reaction. So a redox reaction is a reaction in which oxidation and reduction occurs simultaneously. So in this case, we can see that chlorine Cl2 gains electrons to form Cl minus, whereas I minus loses electrons to form I2. So in this case, gain of electron is called as reduction. You need not write that. And loss of electron is called as oxidation. Let us move on to the next question. Give the color and state of iodine at room temperature and pressure. So the color of iodine at room temperature and pressure is grey black, and the state is solid. Let us move on to the next question. Carbonyl chloride, that is CoCl2, is manufactured by reacting carbon monoxide with chlorine. And this is the reaction given. I can see that the reaction is reversible, and the delta H for the reaction is minus 105 kilojoules per mole, from which I can understand that the forward reaction is exothermic, as the delta H is negative. Now let us read the questions further and understand the question. The process takes place in a closed system and an equilibrium is reached. The condition for this process are 200 degrees Celsius and 200 kilopascals of pressure. Explain what is meant by the term closed system. So basically, a closed system means a system in which no reactants or products can enter or leave. Next question. What does the symbol delta H represent? So delta H represents the enthalpy change. Further, state how the value of delta H shows that the forward reaction is exothermic. So as I told you, delta H value is negative, which shows that the reaction is exothermic. Next, deduce the value of delta H for the reverse reaction. Include a sign in your answer. So for the reverse reaction, the delta H value, the magnitude will be exactly the same. It's just that the sign will be opposite. So in that case, the delta H for the reverse reaction will become plus 105 kilojoules per mole. Let us move on to the next part of the question, in which we have to answer based on the conditions given. So first, the question says, if the temperature is increased, we know that increase in temperature favors the endothermic side of the reaction. and the endothermic side of the reaction is the backward reaction. So the amount of COCl2 in this case will decrease. So for that, the answer for the first part will be decreases. Second, some CO is added, that is carbon monoxide is added. So if the reactant is added, the reaction will always go in the forward direction, forming more products. So in that case, the amount of COCl2 will increase. Third, the pressure is increased. When pressure is increased, the reaction favors the side with lesser particles. So let us see the number of particles on each side. So the total number of particles on this side are 2 and this side are 1. So as the reaction will favor the side with lesser particles, it will move towards the side of COCl2. So the equilibrium concentration of COCl2 in this case also increases. The last part, catalyst is added. Now we know that catalyst does not alter the equilibrium of the reaction, it just affects the rate of the reaction. So here there will be no change. Let us move on to the next question. The equation for the reaction can be represented as shown. The bonds are given and the delta H value is given, and also the bond energies are given. We need to find the bond energy for C double bond O bond, which is basically this bond. Let us start solving this. The first part of the question says calculate the energy needed to break the bonds in the reactants. So let us consider the reactant bonds, which is C triple bond O and Cl bond Cl, for which the values are given in the table, which is 1075 plus 240. Answer comes out to be 1315. Let us move on to the second part of the question. It says calculate the energy released when the bonds in carbonyl chloride formed. So bonds of carbonyl chloride, that is the product for which we need to find the C double bond O bond energy. So that will be 1315 minus 105, which is the delta H value. So the answer comes out to be 1420. Now in the final step, calculate the bond energy of C double bond O. Now to calculate the bond energy of C double bond O, I'll have to subtract the values of 2 CCl bonds from 1420. So that will be 1420 minus 2 times bond energy of CCl, that is 340 into 2. So 1420 minus 2 into 340. So the answer for this comes out to be plus 740 kilojoules per mole. Next part of the question. Complete the dot and cross diagram in figure 4.2 of a molecule of carbonyl chloride. Show only the outer shell electrons. Now we know from the previous page that the structure of carbonyl chloride is C double bond O, Cl and Cl. So in that case, there will be a double bond between carbon and oxygen. There will be a single bond between chlorine and carbon. Now, chlorine will be left with 6 outer shell electrons, both the chlorines, and oxygen has shared 2 electrons. So 4 electrons of oxygen will be remaining in the outer shell. So this is the structure for carbonyl chloride. Let us move on to the next question. Manganese is an element with atomic number 25 in the periodic table. calcium is the element with atomic number 20 in the periodic table. Complete the table 5.1 to show the number of proton, neutrons and electrons in 55 Mn atom and 42 Ca2 plus ion. So, first of all, the proton in Mn, as Mn has an atomic number of 25, means the proton number here will be 25. Neutron number for Mn will be 55 minus 25, which will be 30, and the electron number for Mn will remain 25 as Mn has no charge. So means the electrons is equal to protons. Let us talk about calcium 2 plus. The proton number for calcium 2 plus, as the atomic number is 20, will be 20. Neutron number for calcium 2 plus will be 42 minus 20, which will be 22. And as calcium has a charge of 2 plus, means it has lost 2 electrons. So the electron number will be 18. Let us move on to the next question. Suggest why manganese is expected to form colored oxides. We can see that manganese can show various oxidation states, as it can combine with oxygen with different formulas. So we can say that manganese can form colored oxides because it is a transition element. And this is a property of transition elements. Next, state which property of manganese is shown by the formation of several oxides. So formation of several oxides means manganese has variable oxidation state. So the answer for this will be has variable oxidation numbers. Next part, state the formula of manganese 2 oxide. Now manganese 2 means Mn has a charge of +2, whereas oxygen has a charge of -2. So the formula of the compound becomes MnO. Let us move on to the next question. Mn3O4 is found in an ore of manganese. Manganese metal can be extracted from Mn3O4 using aluminium as a reducing agent. Define the term reducing agent. So a reducing agent is a substance that itself gets oxidized and reduces another substance. So it is a substance that itself oxidizes in order to reduce another substance. Next question. Complete the symbol equation by inserting the formula of the missing product and balancing the equation. So in this question, the product formed will be Al2O3, as aluminium will take up the oxygen, being more reactive. So that will be Al2O3. Now the balancing factor for this will be, here there will be a 3, here there will be a 8, here there will be a 4, and here there will be a 9. Let us move on to the next question, which is a stoichiometry question. MnO2 reacts with dilute hydrochloric acid as shown in the equation. Calculate the volume of chlorine gas formed in centimeter cube at RTP when excess MnO2 reacts with 50 centimeter cube of 0.2 mole per dm cube HCl. So the first question says find the number of moles of HCl. So I know one of the formula for number of moles is volume into concentration, and we have the volume and concentration of HCl. But I'll have to convert the volume into dm cube. So that will be 50 by 1000 into 0.2. The answer comes out to be 0.01. Let us move on to the next part. Determine the number of moles of Cl2 formed. So for that we'll take the molar ratio, stating 4 HCl gives out 1 Cl2. Therefore, 0.01 of HCl will give out how much of Cl2? So the answer comes out to be 2.5 into 10 to the power minus 3. Next part, calculate the volume of Cl2 formed. So the formula for moles related to this is N is equal to volume of gas in dm cube upon 24 dm cube. Here I'll make volume as the subject. So volume will be N into 24. So for this, it will be 2.5 into 10 to the power minus 3 into 24. The answer comes out to be, and that will be into 1000 because we need to find the answer in centimeter cube. And dm cube to centimeter cube, the conversion is into 1000. So therefore, the final answer comes out to be 60 centimeter cube. Next, describe a test for chlorine gas. Now please remember this point. When it is said chlorine gas, you have to describe the test for gas and not the test for the chloride ion. So here the test will be damp, red litmus, and observation is it bleaches due to presence of chlorine. Next question. Explain in terms of collision theory why decreasing temperature decreases the rate of this reaction. So as we all know that as temperature decreases, kinetic energy of particles decreases, collision rate decreases, and hence decreasing the rate of reaction. Let us start with question number 6. The structural formulae of two compounds A and B are shown. So let us first name the compound A and B. I can see that A is a compound having 3 carbon and a double bond. So the name for this will be propene. B is a compound having 4 carbon and a double bond, which will be butene. But the double bond is on the second carbon, so specifically this will be butene. Next, give 2 reasons why the structural formulae of A and B show that they are members of the same homologous series. So in that case, they both have the same general formula, as they both belong to alkenes. So the general formula for alkene is CnH2n. And the next point which proves that they are from the same homologous series is that they have the same functional group, that is the double bond. Next question. State why A and B are both hydrocarbons. The term hydrocarbon is self-explanatory that the compound contains only carbon and hydrogen. Next, write the symbol equation for the complete combustion of A. Now remember, complete combustion of any hydrocarbon always gives out carbon dioxide and water as the product. So A is propene, which is C3H6, reacts with oxygen to give carbon dioxide plus water, for which the balancing coefficients will be 2, 9, 6 and 6. Further, deduce the empirical formula of A. Now what is empirical formula? It is the simplest ratio of the atoms in a molecule. So the molecular formula of A is C3H6, for which the empirical formula, if I simplify, comes out to be CH2. Next question, name compound B. We have already named compound B above, which is but2-ene. So the name of compound B will be but2-ene. Next question, a structural isomer of B is a member of the same homologous series. Draw the displayed formula of this structural isomer of B. So the structural isomer of B will be an alkene where the position of the double bond is different. So instead of the double bond being on the second carbon, I'll place it on the first carbon. So the displayed formula becomes C double bond C, and then complete the valency with hydrogen. So this is the displayed formula of the structural isomer, for which the name is but1-ene, indicating the double bond on the first carbon. Let us move on to the next question. Compound B reacts with bromine at room temperature to form product C. The equation is shown. As we can see that bromine is getting added across the double bond in the compound. So the question, state why this is an addition reaction. Now the characteristic of addition reaction is that it results in formation of only one product. Next, describe the color change in aqueous bromine during this reaction. Now if you remember, this is also the test for unsaturation. That is the test for finding whether the compound has a double bond or not, in which we use bromine water, and the color of bromine water changes from orange to colorless when there is unsaturation present. Name the product C. Now for that we can see that the bromine is on the second and third carbon. So according to the rules of nomenclature, I'll specify the position of the substituent. I'll specify the number of substituent, that is dibromo, and the parent chain, which is butane. Next question. Under certain condition, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D, and carboxylic acid D has 2 carbon atoms. So we know that the carboxylic acid with 2 carbon atoms is called as ethanoic acid. The question says, draw the displayed formula of carboxylic acid D. So that will be 2 carbon acid, which is ethanoic acid. Next question, name carboxylic acid D, which we have already done above. It is ethanoic acid. Last question, complete the symbol equation for this reaction. Now the statement says that 1 mole of B reacts with oxygen. So I write O2 here, which results in formation of 2 moles of carboxylic acid. So 2CH3COOH. And just to balance the oxygen, we will put a 2 here. So this was the last question of this paper. I hope you have understood the paper well. Thank you.